maximum power transfer theorem. Now, first we'll go in any electric circuit, the electrical energy from the supply is delivered to the load, where it is converted into a useful work. Practically, the entire supplied power will not present at load due to the heating effect and other constraints in the network. Therefore, there exists a certain difference between the drawing and the delivering powers. The load size always affects the amount of the power transferred from the supply source. That is, any change in the load resistance results to change in power transfer to the load. Thus, the maximum power transfer theorem ensures the condition to transfer the maximum power to the load. Now, this is the statement of the maximum power transfer theorem. The maximum power transfer theorem states that in a linear bilateral DC network, maximum power is delivered to the load when the load resistance is equal to the internal resistance of a source or the Thevenin's resistance. Now, if it is an independent voltage source, then its series resistance, that is the internal resistance Rs, or if it is an independent current source, then its parallel resistance, that is the internal resistance Rs, must equal to the load resistance RL to deliver maximum power to the load. Now let us consider a case. A resistive network contains independent and dependent sources. A load is connected to a pair of terminals labeled AB. Now what value of load resistance permits maximum power delivery to the load? We'll see. Now this is the case where A and B are the two terminals. These are the two terminals, and this is the load resistance. Resistive network containing independent and dependent sources. Okay. Now let us take the Thevenin equivalent circuit of this. This will be your VTH, RTH, is the two terminals, and this is the RL. Now look at the power developed in the load. Your P will be what? It will be I square RL, which is equal to VTH by RTH plus RL. This is the I part, square of this into RL. Now to find the value of the load resistance that maximizes power, what we need to do is that we have to differentiate this power part. So we are doing dP by dRL. We are getting this, and we have to equate it to 0. So we are equating it, and we will get something. So after certain simplifications, we will get the expression that RL is equal to RTH. Now the maximum power delivered to the load, what will be the maximum power? Your Pmax will be I square RL. Now I square is V square TH by 2RL whole square. Because in order to have maximum power, you see, this was our experience, our expression, that is VTH by RTH plus RL. Now in order to have maximum power, we have found that this RTH should be equal to RL. So it will be VTH by RL plus RL, that is 2RL. So the same expression is drawn here, VTH square by 2RL whole square into RL. So we are getting this VTH square, this RL and RL square cancels out. So it is VTH square by 4RL. That is the expression for maximum power. And what is the condition for maximum power? The condition for maximum power is that the load resistance has to be equal to the Thevenin's equivalent resistance, that is the RL should be equal to RTH. Now regarding the Thevenin's equivalent resistance, it has already been discussed in this forum, in our website. You can consult that. Okay, now let us take one example. Let us find the value of RL for maximum power transfer to RL. Now see, this is the voltage, this is the resistance, these are the internal resistances, and this is the load resistance. There are two terminals A and B. Okay, now we are determining the Thevenin's equivalent resistance. Our VTH, Thevenin's voltage, will be 150 by 150 plus 30 into 360, that is equal to 300 volt. And what will be the RTH? Your RTH will be, these two are in parallel connected, these two are parallel connected, so it's 150 into 30 by 150 plus 30, that is equal to 25 ohm. So VTH is 300 volt and RTH is 25 ohm. So this expression can be simplified and written as this. This was the actual circuit. This is the Thevenin's equivalent circuit. Now, according to the maximum power transfer theorem, we already said that the maximum power will be transferred when this load resistance is equal to RTH, Thevenin's equivalent. So your RL will be 25 ohm in order to get maximum power. Okay, now let us calculate the maximum power that can be delivered to RL. We have seen the condition for maximum power, that is RTH equal to RL. Now we will find out that what will be the maximum power. Now this is the Thevenin's equivalent circuit. Here is the RL. So your power will be I square RL, that is equal to 300 by 50 whole square. This is your I square and this is the RL. So your P is equal to 900 watt. Now what percentage of the power delivered by the load by 360 volt source reaches RL? This is the circuit diagram. The VAB is 150 volt, so your I source will be 360 minus 150 by 30, that is equal to 7 ampere, and your PS equal to minus IS 360, that is this much of watt. Thank you.